First is alpha dot, I write 0 V, and everyone know about what is 0 V.
Zero vector.
0 vector. And can someone tell me what is the product? Alpha dot 0 V, that is equal to something for every alpha in R. Alpha R is field. Yes, what is the result? Alpha dot 0 V equal to? Yes, anyone? It is not difficult question. What is the product? Alpha dot 0 V equal to?
Zero.
Yes, quickly. Anyone?
Zero vector.
0 vector. Alpha dot 0 V is 0 vector. 0 V. Very good. Second is, if we take any scalar 0 and if we multiply this by any vector x, and what is the product?
Zero.
It is 0. Right? You can, for every x in R, x in vector. Third, v, 0 V, even we can discuss about this in the beginning. Just a minute. So, okay. But before this, can someone tell me, is 0 V into 0 into x, that is equal to 0? Is it true?
Yes, sir.
How? How it is true?
सर x कोई भी वैल्यू हो सकता है, किसी भी वैल्यू को मतलब हम 0 से मल्टीप्लाई करेंगे तो 0 ही आता है.
But what is x? Here
X is vector.
0 is scalar and x is vector, and what is the product?
Vector.
It is vector. So it is not 0, but it is 0 V. And 0 V plus 0 V, it is also 0 V. Right? And the fourth part is that is, if alpha dot x is equal to 0, can I write 0 or 0 V?
0 V.
Alpha dot x is equal to 0 V, then either alpha equal to 0 or x is equal to 0 vector, 0 V. And fifth part is, you can multiply any vector with -1 and you get -x for every x in. So all of you know about all these properties. Is the property clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So one result which is very important, which is very helpful to solve this these properties. What is the result? That is, if I can take any, for any x in V, you can take any vector in V such that x plus x is equal to x. Can you say something about this x? have any comment about this vector? What is the suitable value for
Sir,
this
x
x?
is
X is equal to
0v.
0v. So x is equal to 0v. Because x is a vector, so we write x is equal to 0v. So x is equal to 0v is the only vector which satisfies this condition. So we can say 0v plus 0v is equal to 0v. And if it is a real number, then we know that 0 plus 0 equal to 0. When we talk about field, then 0 is the only number which satisfies this condition. If we say alpha plus alpha equal to alpha, then alpha is equal to 0 is the only value which satisfies this condition. When we talk about vector, then we take 0v. Is it clear? How can we prove this? Can you prove this? How we get x is equal to 0v? How we get x is equal to 0v? This is my question. Yes, quickly, anyone? What is the given condition? X plus x is equal to x. This is the given condition. We have to show that 0v is the only vector which satisfies this condition. But how can we prove this?
x is equal to x minus x, then x is equal to 0.
X is equal to
0. Just subtracting x from both sides.
why we subtract this?
सर एक x को दूसरी तरफ ले जाएंगे तो 0 हो जाएगा.
That is
Sir,
the yes.
sir, multiply with 0v both side.
Then
No
what?
sir, तब तो whole value 0 हो जाएगी. Sir, we simply do. We have to x plus x, so x is equal to x minus x. So x is equal to 0.
Why we take minus x? Minus x क्यों ले रहे हैं?
सर दूसरी तरफ ले जाते तो वैल्यू माइनस हो जाती है.
So you're talking like this, right? If we take 2 plus 3 equal to 5, then we can say that 3 equal to 5 minus 2, right?
Yes sir.
But the thing is, yeah, you can do directly because we know that. But how we can calculate this? How we can find ये -2 यहाँ कैसे आया? I know everyone know about this. We can write 3 equal to 5 minus 2. But how we can write this? In vector, how we can write this? Where -2 comes? Where minus x comes? ये x कहाँ बिलोंग कर रहा है?
Zero.
Vector space.
Sir,
V is a vector space.
Yes sir,
V
तो
is-
उसकी
V
एडिटिव
is-
इनवर्स होगा.
Yes, अगर x बिलोंग करता है वेक्टर स्पेस में एंड वेक्टर स्पेस में एडिटिव इनवर्स बिलोंग करता है. Is it clear? कोई चीज डायरेक्टली नहीं होती है. आप you think about this. How we write all these concepts. So because x belongs to V, so there exists x minus x belongs to V. Where minus x is the additive inverse of x. So that's why we write minus x plus x is equal to minus x plus x. Is it clear?
Yes sir.
Now, what is the next step? Quickly, don't take too much time. This is simple algebra.
X equal to 0v.
How we can write?
0v plus x is equals to.
Where we get
Sir, by
0v?
using associativity property under addition.
Yes, by using associativity, we can write this as minus x plus x plus x. Don't jump. You directly go to the last step. But there are some steps behind this. We have to do one by one. Because of the associativity, we have already discussed about this. That's why we write this step. And what is the value on right hand side? Because additive inverse. So this
0
will be
V.
0v. We can write this is 0v. And similarly, because minus x is the additive inverse of x, so we can write this as 0v. 0v plus x is equal to 0v. And what is 0v? 0v is the additive identity of in the vector. And x plus, when we add any vector with 0v, what we get?
X.
X. So x is equal to
0 V.
0v. So this x is then we find the value x is equal to 0v. Now is it clear to everyone?
Yes, sir.
Yes, sir.
But how we can find? Now one student told me that 2 plus 3 equal to 5. We can take 2 to be common. So yes, we know. अब आप already पढ़ चुके हो तो you directly. But the logic behind this, because we know that 2 additive inverse of 2 is minus 2. So we can write 2 plus minus 2 plus 2 plus 3 equal to minus 2 plus 5. And similarly, you using the associativity property, minus 2 plus 2, and it is 0. 0 plus 3, it is 3. 5 minus 2, that is 3. Is it clear?
Yes, sir.
So what is the suitable value for x plus x equal to x? X equal to 0v. Take 10 seconds to quickly revise this part. So now, what is the first part? Now we prove first part. Alpha dot 0v equal to 0v. So how we can prove this? Yes, anyone? So we can do this by two ways. So first method, I can write first method. Alpha dot 0v. Can I write as alpha dot 0v plus 0v? Can I write 0v as 0v plus 0v?
Yes, sir.
Because we have already proved x is equal to x plus x and x is equal to 0v. And now we can write alpha dot 0v. Alpha dot, we know that in vector alpha dot x plus y equal to alpha dot x plus alpha dot y. So x is a vector, y is a vector, so alpha dot 0v plus alpha dot 0v. So we get alpha dot 0v equal to alpha dot 0v plus alpha dot 0v. Is it clear? क्या ये सिमिलर आपको दिख नहीं रहा है कि अगर मैं इसको x ले लूं तो x is equal to x plus x. If we take x is equal to alpha dot 0v, तो x is equal to x plus x. और x की कौन सी वैल्यू सेटिस्फाई होगी? 0v. Alpha dot 0v equal to alpha dot 0v plus alpha dot 0v. This implies that alpha dot 0v equal to 0. Because we can write the reason, because x plus x is equal to x. For every x in v, then x is equal to 0. So by using the property we can write this. Otherwise you can also prove this, because we know that 0v plus 0v equal to 0v. This is the second method. And you can multiply both side by vector scalar alpha dot 0v plus 0v, that is equal to alpha dot 0v. Alpha dot 0v plus alpha dot 0b is equal to, I can write alpha dot 0b plus 0b, because 0b is the additive identity of the vector, and by the left cancellation law you can write alpha dot 0b equal to 0b by left cancellation law. So we can prove this by using the property. Is it clear?
Yes, sir.
Similarly, 0 dot x is equal to 0v. 0 dot x is equal to 0v. So similarly, we can prove this. 0 plus 0 equal to 0. We know that. Can we write 0 plus 0 as equal to 0?
Yes, sir.
So multiply both sides by vector. 0 plus 0, 0 dot x is equal to 0 dot x. 0 dot x. Again, you can use the same property. 0 dot x is equal to 0 dot x, and 0 dot x plus 0 dot x is equal to 0 dot x plus, what is the identity in vector?
0v.
0v. So this implies that 0 dot x is equal to 0. And in second part, if we take x is equal to 0 into, or we can say we start with uh, yeah, here in this case, अगर मैं इसमें 0 भी ऐड ना करूं, 0 भी ऐड ना करें हम, तो 0 डॉट एक्स प्लस 0 डॉट एक्स इज इक्वल टू 0 डॉट एक्स, और 0 डॉट एक्स को मैं, अगर मैं 0 डॉट एक्स को मैं, आई कैन टेक u, and u plus u equal to u. What is the value of this u?
0v.
0v.
So u is equal to 0v. So if I write the property, then directly without adding the identity element, I can say that 0 dot x equal to 0v, because u plus u equal to 0v. So try the other part. You can try by using the property. You can try the other part. Okay. Now quickly I go to the sequence. How we can add sequence if we have a vector. Let v be a vector which is defined as, I can say this is S. S is a set of all sequence. This is defined. When we define something, then we use this notation. And now in modern mathematics, most of the you know that we use this bracket to use write a sequence. But now in most of the books in modern mathematics, we use this notation for sequence. This small bracket. Right? So I use small bracket. This represents sequence, such that this xn, all the term of the sequence, is belongs to real number. This is be the set of all real sequence. Then V is a vector space. Vector space under over the field of real number under the following operation. Under the following operations. What are the operations? If we take addition, how we add sequence xn comma sequence yn, that is xn plus sequence xn plus sequence yn is defined as xn plus yn. It means we take add first term of the sequence with the first term of the other sequence, and similarly the corresponding terms. The second is scalar multiplication. We can take alpha from field and xn from vector, that is alpha dot xn, and this is defined as alpha xn. Then by using these addition and scalar multiplication, this V become a vector space. Now we know that for every first properties, this is A1, for every xn, yn belongs to V, or we can say S, xn plus yn, xn plus yn, that is equal to, that is defined as xn plus yn, and we know that they are real number because they are over the field is real number, so we get the entries, real entries, and we know that in real number x1 plus y1 equal to y1 plus x1, so we can write this as yn plus xn, and we can separate them as yn plus xn. So they satisfy the commutativity, they satisfy the associativity. There exists a zero sequence, we call that as a null sequence or zero vector, that is the additive identity, and minus xn is the additive inverse. Similarly, it satisfies all the properties a1 to a4 and s1 to s4. So this become a vector space. You can try this. Operation is defined. You can try each and every property. Now the next thing is, if I take all the sequence, जितने भी sequence मैंने define, जितने भी sequence होंगे, अगर मैं इनको define करूं, set of all sequence, all real sequence, I can take a real sequence. इसको मैं define करता हूं एक square box इस तरीके से, and set of B is set of all bounded sequence, all bounded sequence. इसको मैं define करता हूं triangle से. Triangle represents set of all bounded sequence. C, set of all convergent sequence, all convergent sequence. Zero, set of all convergent sequence converging to zero, converging to zero. Sometimes we call this as a null sequence, and we denote this by let it be rectangle, right? So can you tell me which one is a subset of others? Is S a subset of, is B a subset of S, and this is a subset of C0 and this is subset of C? Is this the right way? Or is C0 a subset of C, is subset of B, is subset of S? Or is C a subset of C0, is subset of B a subset of S, or is C0 a subset of B a subset of C a subset of S? If I write this as 1, 2, 3 instead of 4, I can write 1, 2, 3. See 1, 2, 3, and 4. Yes, tell me which one is correct?
Second, sir.
Second one.
Second.
Yes, sir.
Okay. Okay. Tell me how.
Because sir, नॉट नल सबसे पहले आएगा सर, उसके बाद कन्वर्जेंट सीक्वेंस आर बाउंडेड सीक्वेंस, बाउंडिंग सीक्वेंस आर सीक्वेंस.
कन्वर्जन, बट कन्वर्जन सीक्वेंस बाउंडेड में क्यों कंटेन्ड हो रहे हैं? बाउंडेड वाले ये वाला क्यों नहीं आया? इस वन ये फोर्थ क्यों नहीं है?
क्योंकि सर इसमें नॉट नल भी दिया हुआ है ना.
Bound, it is not exactly that bounding sequence are convergent.
Because
क्योंकि ये जरूरी नहीं कि बाउंडिंग सीक्वेंस जो है वो कन्वर्ज,
हाँ,
बट
तो
कन्वर्जेंट सीक्वेंस जो होते हैं वो बाउंडेड होते हैं.
हाँ, वेरी गुड. बट क्या मुझे उसकी स्टेटमेंट करेक्ट करके बताओगे? व्हाट इज द करेक्ट स्टेटमेंट? What is the correct statement? Every convergent sequence is bounded. Is it true?
यस सर.
Okay. So देखो null sequence को हमने कैसे define किया? This. So second is the true right answer. जितने भी null sequence हैं जो जीरो को converge कर रहे हैं, मतलब वो converge कर रहे हैं ना, और C convergent है, वो किसी को भी converge कर सकते हैं, वो जीरो को भी कर सकते हैं, 1 को भी, 2 को भी, माइनस को भी, -1 को भी, -2 को भी, 1/2 को भी, √2 को भी, any real number. It means ये स्पेसिफिक जीरो को कन्वर्ज करने वाले कन्वर्जेंट के अंदर कंटेन्ड हो रहे हैं, और एवरी कन्वर्जेंट सीक्वेंस इज बाउंडेड, और सारे के सारे ये जो सीक्वेंस हैं वो कहाँ कंटेन्ड हो रहे हैं? सीक्वेंस में. सो the diagram is look like this. This is set of sequence which converges to 0. This is contained in circle. Circle is set of convergent sequence, and this contained in triangle. And then it contained in square. So now the question is, this is also sequence, this is also a vector space. V set of bounded sequence, they also become a vector space under the same operation. Set of convergent sequence, they also become the vector space. C0, they also become the vector space. Now what come? इससे क्या हमें result find out किया? The subset of a vector space is again a vector space, but under the same operation. The operation is defined. It is xn plus yn. We define addition like this. We define scalar multiplication like this. Under the same operation, B is a vector space, C is a vector space, C naught is a vector space. Now what we come? What क्या conclusion निकलता है इससे? The subset of a vector space is again a vector space. So B is a subset of S. So what we call? B is also a vector space under the same operation जो हमने S के ऊपर डिफाइन की है. So we can say if I take W equal to B, set of all bounded sequence को हमने W लिया, और S हमने क्या लिया हुआ है? S is equal to vector space V. set of all sequence. So we can say W, because W is a subset of V, so we can say W is a vector. This is the symbol for vector space, subspace, right? So W is a subspace of V under the same operation. Important thing is under the same operation. जो एडिशन एस के लिए डिफाइंड है, बी के लिए डिफाइंड है, वही डब्ल्यू के लिए डिफाइंड होगा. जो ऑपरेशन, अब आगे में अगर इसको मैं डब्ल्यू की जगह सी को मैं यू ले लूं, कैपिटल यू, यू इक्वल टू सी, सो वी कैन से सेट ऑफ ऑल कन्वर्जेंस इक्वल, तो यू इज अ सबसेट ऑफ डब्ल्यू, सो वी कैन से यू is a vector space of W, subspace of W, and W is a subspace of V. So can I say U is also a subspace of V?
Yes, sir.
How? How can I say?
Subset of W.
U is a subset of W, so U is a subspace of vector space W.
Yes, sir.
W is a subspace of V. So can I say U is also a subspace of V?
Yes, sir.
How can I say?
Because U is also satisfying all the properties that W is satisfying.
Yes, but because of transitivity. You know about the transitive property? If A is a subset of B, B is a subset of C, then A is a subset of C. If A is related to B, B is related to C, then A is related to C. U is a subset of, U is a subspace of W, W is subspace of V. So by using the transitivity, we can say U is a subspace of V. So can we use the same concept to C naught? If I take T, T is a set of all convergence sequence that converges to 0. So can I say that T is a subspace of U? Because T is a subset of U. T is a subset of U. So under the same operation, addition and multiplication, we can say T is a subset of a subspace of U. Is it clear?
Yes, sir.
Now
Yes,
we come.
sir.
Now we come to the definition of subspace. The important thing is it is a subspace. It is a vector space, but because it contained in some other vector space, so it is, because it is a subset of some set which is a vector space, so that's why we call it is a subspace. So how we can write the definition? Let W be a non-empty subset of vector space V. Then W be a vector subspace or we can simply say subspace of V if W itself is a vector space under the operations induced from V under the same operation, right? That is the first property, 0 V belongs to W, at least identity element must be in W. Second important thing is if x comma y belongs to W, then x plus y also belongs to W. Third, if alpha belongs to field, and if I take field to be real number, and x belongs to W, then alpha dot x also belongs to W. Right? So if we have a vector space V under the operation addition and multiplication, if we have W under the same operation addition and multiplication, then W is a subspace. If I take x in W, y in W, then x plus y also in W. And if I take any scalar from alpha from field, then alpha dot x also belongs to W. For any alpha in R. R is a field. You can take F also. Alpha belongs to field F. Right? So, and the necessary and sufficient condition is for vector space to be a subspace is that for any x alpha beta in field, let it be R, and given any xy in W, this implies that alpha dot x plus beta dot y, this also belongs to W. So this is the necessary and sufficient condition. अगर आपको किसी W को वेक्टर स्पेस V का सबस्पेस बताना है, तो what we do, you can take any xy in W, alpha beta in field, alpha x plus beta y अगर W में आ जाता है, then we can say that W is a subspace of vector. So this is very important. Even I'm not going to prove this, but you can think about this, how we can go, how we can prove this. Right now I am just discussing about this. So two vectors are the subspace of a vector space. What are those two vectors? Two vectors are always a subspace of vector space. Can someone tell me what are those vectors? If I take 0v as a vector, is it a vector space? If I take
Yes, sir.
we have already discussed in the last class, and we know that W को subspace होने के लिए, this is the first condition. First condition, 0v must be in W. So 0v, if we take only 0v, then it is a subspace. So 0v and a vector, if I take W is equal to same vector V, then they are the subspaces of vector space. So we call them trivial subspace. Trivial subspace. Right? So vector space or 0v identity element. अगर हम सिर्फ दो सबस्पेस की बात करें, 0v is a subset of V, and if we take W to V equal to V, then they are without any, हम इनको चेक नहीं करेंगे, they are trivially subspace of vector space. But if W is not equal to 0v and W is not equal to V, and even then W is a subspace of V, 0v भी नहीं है, वेक्टर स्पेस भी नहीं है, लेकिन फिर भी W सबस्पेस है, तो it is called non-trivial subspace. It is called non-trivial subspace or proper subspace. Proper subspace. So though trivial or improper, we can also call them improper subspace. Right? So now we have discussed that Rn under the operation addition and multiplication, it become a vector space. It is a vector space. Is this question clear to everyone? We have already discussed that Rn is a vector space.
Yes, sir.
Yes, sir.
Can I take particular case R2 n equal to 2? So R2 under the operation addition and multiplication, usual addition and usual multiplication, is it a vector space?
Yes, sir.
Yes, it is a vector space. Right? So R2 कैसा होगा? R2 is like this. This is R2. Now we think about this geometrically. इसके सबस्पेस क्या होंगे? R2 के सबस्पेस क्या होंगे?
0
0. तो 0 कैसा होगा?
Zero vector.
हाँ, 0 वेक्टर कैसा होगा? किस how we can write this 0v as
0
Zero
0
0 0. So this 0, this is 0, right? 0 0. So we write this 0 0 as 0v vector because it belongs to vector. So if I take w to be 0 0 only, is it a vector space, subspace? Sorry, is it a vector space?
Yes, sir.
Yes, it is a vector space, right?
Yes, sir.
How we can add 0 0 comma 0 plus 0 comma 0, that is equal to 0 plus 0, first element with first, second with second, and we know that 0 is a real number. 0 is a real number, and in real number 0 plus 0 equal to 0. So it is again we get 0 0. Right? So what we get? Yes. So 0 plus 0, that is equal to 0. And if we take any alpha scalar alpha into 0 comma 0, what we get? Alpha dot 0 b equal to 0 b. So we get 0 0. So that's why mostly student क्या लिखते हैं? Alpha dot 0 b that is equal to 0. This is not correct. हमने देखो प्रूफ किया alpha dot 0 b equal to 0 b. This alpha dot 0 b equal to 0 b. अगर आप इस तरीके से लिखेंगे तो वो कंफ्यूजन नहीं रहेगी. बट अल्फा डॉट 0 इक्वल टू 0 b इक्वल टू 0, दिस इज रॉन्ग. क्यों? बिकॉज अल्फा डॉट 0 b is 0 dot 0 0 comma 0, and when we multiply this become alpha dot 0 comma alpha dot 0, and alpha dot 0 it is 0 v it is 0 comma 0, because 0 is a real number, alpha is a real number, so product of two real number is again a real number, and 0 comma 0, this is nothing but this is 0 b. So alpha dot 0 b equal to 0 b. Is it clear?
Yes, sir.
So now I am taking a subset. I am taking this subset, first quadrant. I take w is equal to w is a subset of R2. V is equal to R2. I take V is equal to R2. So W is a subset of first quadrant is a subset of R2. Is it clear? होगा कि नहीं होगा ये?
Yes, sir.
तो is it a subspace?
Yes, sir.
how can you say that this is a subspace? Take 10 seconds, think about this. Without thinking, don't say yes or no.
Sir, it is not because inverse नहीं आएगा sir इसमें.
Inverse नहीं आएगा. Okay. If I take first quadrant में, I can take any one number, right? I take let it be यहाँ से 2 ले लिया, यहाँ से 3 लिया. I can take 2, 3. So what is the additive inverse of 2, 3?
-2 -3.
Is this belongs to W?
No sir.
So is it a subspace?
No sir.
No, sir.
It is not a subspace. Is this point clear to everyone?
Yes sir.
Yes, sir.
How can we make this a subspace? चलो इसको subspace बनाते हैं. आप कैसे बनाएंगे? I take, मैंने पहले initial क्या किया था? I only take the first quadrant. क्या प्रॉब्लम आई? क्यों ये वेक्टर स्पेस नहीं बना?
W00 है सर.
W जो है फर्स्ट क्वाड्रेंट था. W हमने फर्स्ट क्वाड्रेंट लिया था. अब मुझे वेक्टर स्पेस बनाना है इसको. कैसे, कौन सा पार्ट और ऐड करूं कि वेक्टर स्पेस बन जाए?
Third quadrant.
थर्ड क्वाड्रेंट. If we take W to be this, तो अब W क्या हो गया मेरा? W is equal to first quadrant plus third quadrant. Now W is a subset of V. W अब subset है R2 का कि नहीं है?
Yes sir.
Now is W be a subspace?
Yes sir.
Yes, all of you. Is W be a subspace?
Yes, sir.
Yes sir.
Yes. Now W is a subspace. W is a subspace of V. So these are some geometric interpretation how we can think about this. ऐसा नहीं है कि क्वेश्चन आप करेंगे तो आप सबस्पेस का कांसेप्ट आपको क्लियर हो. Try to think about this geometrically. Draw some picture, create some examples, and think about them. Right? Okay. Now quickly tell me.
क्वेश्चन था.
Yes.
सेकंड और फोर्थ क्वाड्रेंट में क्यों नहीं होगा सर सबस्पेस W?
मैंने सबसेट लिया तो मेरे पास सबसेट क्या है? एक, अगर मेरे पास वेक्टर स्पेस V है, सेकंड और फोर्थ में क्यों नहीं होगा?
यस सर.
नहीं, मैंने तो ऐसा नहीं कहा सेकंड और फोर्थ में नहीं होगा. मैंने ऐसा बोला आपसे कि ये नहीं होगा सेकंड फोर्थ में?
यस, नहीं बोला सर.
नहीं, मैं, हाँ, सेकंड फोर्थ में अगर आप लोगे तो हो जाएगा. बट क्वेश्चन इज, मैंने पहले फर्स्ट क्वाड्रेंट लिया. फर्स्ट क्वाड्रेंट में एक कंडीशन आई कि इफ आई टेक एनी वेक्टर, एनी एलिमेंट 3,5, जब मैंने उसका एडिटिव इनवर्स निकाला तो वो -3 और -5 है, तो फर्स्ट क्वाड्रेंट में नहीं था. अब -3 और -5 तो यही आएंगे ना, सेकंड और थर्ड फोर्थ में नहीं आएंगे. सेकंड में लेते हैं तो सेकंड में x नेगेटिव होता है तो -3 तो आ जाएगा, बट 5 नेगेटिव नहीं आएगा. अगर मैं फोर्थ में आता हूँ तो 3 पॉजिटिव होगा और 5 नेगेटिव हो जाएगा. तो मुझे तो लेकिन 3 और 5 का एडिटिव इनवर्स क्या चाहिए? -3 और -5. तो वो तो यही आ रहा है ना, -3 और -5. इसका मतलब कोई भी आप फर्स्ट क्वाड्रेंट में एलिमेंट क्या होते हैं? फर्स्ट क्वाड्रेंट में सारे के सारे x और y कौन से होंगे?
All positive.
x is non negative, not positive. x is greater than equal to 0 and y is greater than equal to 0. और सारे पॉजिटिव और वी कैन से नेगेटिव, नॉन नेगेटिव नंबर्स का एडिटिव इनवर्स क्या होगा? नॉन नेगेटिव, नॉन पॉजिटिव. नॉन पॉजिटिव इज 0 का तो 0 हो जाएगा, बट 2 का -2 होगा, 5 का -5 होगा, 2,5 का -2, -5 होगा, और वो लाई कर रहे हैं थर्ड क्वाड्रेंट में. इज इट क्लियर?
Yes, sir.
Yes, sir.
तो हमें ये देखना है कि कहाँ पर उसका एडिटिव इनवर्स एग्जिस्ट कर रहा है. Now if I take this is R2. अब R2 में डायरेक्ट वेक्टर स्पेस बोल रहा हूँ क्योंकि हमने Rn पढ़ लिया हुआ है. तो Rn की बात होगी है तो R2, R3, R4 ये सारे के सारे क्या है? They are सब वेक्टर स्पेस. So I can take V equal to R2 be a vector space. Now I take W. W में x comma y, this belongs to R2. This belongs to R2 such that x plus y is equal to 1. x plus y क्या होना चाहिए? 1 होना चाहिए. Is Wb a subspace of V? Is Wb a subspace of V? If you know the answer, click only on raise hand option. Don't say answer. Verbal answer नहीं चाहिए. You click on raise hand option. If you know the answer. Yes, Lakshmi. Yes, Lakshmi.
It is not a vector space.
It is not a vector space. Okay, very good. But how? Can you tell me how?
If we take an example,
No, we have already taken some. Yes.
मतलब R square में हम कोई example ले जैसे कि 2,0.
Just a minute. Your voice is not audible to me properly. Can you repeat?
सर हम example ले R square में कोई element जैसे 2,0.
2,0.
2,0 नहीं आ सकता सर 1,0 क्योंकि x plus y is equals to 1 है ना.
Okay. 1,0.
और अगर हम कोई अल्फा ले ले.
Alpha, yes.
Alpha can be any number.
Yes, alpha can be any real number.
It can be 2.
Okay, it can be 2. Alpha equal to 2.
और अब 1 इसको मल्टीप्लाई करके स्केलर मल्टीप्लिकेशन में ये सब स्पेस में प्रूव हो पाएगा.
So 2,0. Very good. So it is 2,0. But ये 2,0 को कैसे बोल सकते हो बेटा कि ये वेक्टर स्पेस नहीं बनेगा, सब स्पेस नहीं बनेगा.
कंडीशन दी हुई है कि x plus y is equals to 1. But here it is 2,0. So 2,0. When we add 2 plus 0, then it is 2.
Yes.
So it does not satisfy the.
Very good. Very good. So can you Lakshmi, can you tell me how the line look likes? How we can plot the line? इसकी लाइन बताओगे कि how we can think about this geometrically? X plus y equal to 1.
It is अगर या तो ये x एक्सिस पे पॉइंट लाई करेगा या तो ये y एक्सिस पे लाई करेगा पॉइंट.
Yes. Is it a vector space or not? Yes, Lakshmi, can you repeat? Can you repeat your answer?
No, sir, it is not a vector space.
It is not a vector space. Now, how we can plot this x plus y equal to 1? If we take x to be 0, y to be 1, it is 0 comma 1. If we take x to be 1, y to be 0, it is like the point lies here. And if we draw a line, so this is a line, right? X plus y. So it is not a vector space. Okay. So if I take w is equal to xy such that xy in R2 such that x plus y to be 0, and my vector space V equal to R2. So here what we proved, W is not a vector space of V, subspace of V. Okay. So now the next question is Wba a subspace of V? If you know the answer, click on raise hand option. Yes. You click. विकास
सर सबस्पेस होगा सर,
सबस्पेस होगा, कैसे होगा?
क्योंकि सर उसमें एडिटिव इनवर्स भी एग्जिस्ट करेगा और उसकी, क्योंकि सर x का एडिट x प्लस वाई इक्वल टू 0 है, तो सर वो x प्लस वाई इक्वल टू -0 भी होगा उसमें, और दोनों ही R2 में है तो सर वो बिलोंग करेगा।
दोनों ही R2 में है।
यस सर।
विकास के अकॉर्डिंग W इज अ